Section 7.4 Estimating the population proportion with confidence interval. For these sessions, we're going to learn how to use the central limit theorem to construct a confidence interval for population proportion. Remember on the section 7.3, we talk about the central limit theorem. We do have a three requirements before we apply the central limit theorem. And for these sessions, we're going to learn how to construct the confidence interval for the population proportion. Look at this example. The Kaiser Health Tracking Poll surveyed 1,504 American adults and asked them if they support or oppose the requirement that private health insurance plans cover the full cost of birth control. The poll found that 61% of respondents support this requirement. What percentage of all American adults supports this requirement? So you could see that we do have the survey, and this is the number of the people who get this survey, and they found it out 61% of respondents support this requirement. So you're gonna know this is gonna be the sample proportion. Right now, we want to know what is the percentage of all American adults support this requirement. This is talking about the population. So remember that we draw the sample from the population, and then we're going to calculate the sample proportion. And we're going to use the sample proportion to estimate the population proportion. So they want to know what is the population proportion of the all Americans support this requirement. So first, remember in the section 7.3, we talk about the estimator, the sample proportion. This is unbiased. Unbiased means we can use the sample proportion to estimate the population proportion. Since we know the sample proportion is 61%, we could say the population parameter will be very close to 61%. Okay, so we know the sample proportion now, and we want to find the standard error. Okay, remember the formula for the standard error? I want you guys try to plug in this formula. Find out the standard error, or you could call this as the standard deviation. Plug it in. Make sure you guys know how to use your calculator. Okay, you should get 0.0126. Hey, I want to remind you guys that when you guys plug into the calculator, try to put everything into your calculator and press enter. Don't separate to do it part by part, okay? So the standard deviation or the standard error, you could say it's going to be 1.26%. Okay, so think about it. We do have 1,504 American adults. So we could say this sample size is large. And the probability distribution of the sample proportion is approximately. Okay, think about the requirement for the central limit theorem. We want to be random and independent sample. Second one, and the sample proportion times the sample size, 0.61 times 1,504, has to be greater than 10. And also, the population size has to be 10 times of the sample size. So for sure, we do have more than 50,000 American on the population. So we could apply the central limit theorem. So we could approximately normal. That would be the normal distribution, and that would be symmetric, or you could say center around the true population proportion. So what percentage of all American adults supports this requirement? We're going to think about the empirical rule. We do have a 68%, 95%, and 99.7%. So this time we only choose like 95% in here. Okay, so 95%, that is about 2 standard deviation errors away from the population proportion. Okay, remember the empirical rule, 95% is talking about the sample proportion plus minus 2 standard deviation. That will be about 95%. So now we're going to calculate 2 standard deviation. Okay, standard deviation, that means it's going to be standard error. And then we find the standard error from the previous slide, right? So we're going to multiply it. So you could say we have a 95% confident that the value of the population proportion is within 2.5%. Okay, when you times 100% for this guy, that will be 2.52. So it's within 2.5% points of 61%. This 61% talking about the sample proportion. Okay, since we know 95%, that will be plus minus 2 standard deviation. So I'm gonna use the sample proportion plus minus 2 standard deviation here. Okay, 1 minus and then 1 plus. You're gonna get 58.5% and 63.5%. So we could use the sample proportion to estimate the population proportion. And the population proportion, that will be in between 58.5% to 63.5%. Okay, we could consider this is gonna be my confidence interval. Okay, 95% confidence interval. When we draw the conclusion, you're gonna say we are 95% confident that the population proportion is in between this. And we call this as the confidence interval. Okay, so the first example, I just showed you guys how to construct the confidence interval. But we will be going through more details because like the 95%, we will just think about like the empirical rule, and then we're gonna plus minus 2 standard deviation to get this one. How about if we want to construct 91% confidence interval or 97% confidence interval? Okay, one more time. The first example, I just give you guys the heads up how you find the confidence interval. Okay, now we're gonna go through into the details. So first, a point estimate. I need you guys to remember this definition. A point estimate is a single value used to approximate a population parameter. Okay, so you could think about it. We draw the sample from the population, and then we're gonna use the sample data to calculate the sample proportion. And we call this sample proportion will be the point estimate. Okay, remember from the previous sessions, we talk about we have the cat people and the dog people, right? We do have 8 people in the population, and then we only draw 4 people from the population. And that 4 people, that will be my sample. And then we're gonna calculate the sample proportion for the cat people, right? That sample proportion of the cat people, we consider this is gonna be the point estimate. And then point estimate is talking about the statistic. Okay, remember the statistic? Statistic is a number who describe the sample. So I can mention about like the sample proportion, sample mean, sample standard deviation. That will be the point estimate. Or even like the sample variance. Okay, remember what is the point estimate, right? Talking about the statistic. It can be sample proportion, sample mean, sample standard deviation, or sample variance. Okay, what is the confidence interval? Confidence interval is a range of values used to estimate the true value of the population parameter. A confidence interval is sometimes we could use the CI to represent it. Confidence interval. The difference between the point estimate and the confidence interval. Point estimate is a single value, okay, only a one numerical to estimate the population parameter. But confidence interval, that will be a range of values. Okay, it can be given a range of values to estimate the population parameter. We already know how to find the point estimate. You guys know how to find the sample mean? sample proportion or sample standard deviation, right? We cover it from the midterm one. And then now we want to construct the confidence interval. That will be a range of values. We could construct the confidence interval for the population mean, or population proportion, or population standard deviation, or population variance. But for this case, we only need to know how to construct the population mean and the population proportion. And for these sessions, we only cover this guy. Okay, chapter 7, we only cover the population proportion. Confidence level is the probability, such as 0.95 or 95%, that the confidence interval actually does contain the population parameter. I'm gonna explain this part for the next slide. Okay, on the first example, we work on the 95%, okay, but it can be anything. It can be 91%, 93%, 97%, or even though you could construct 85% confidence interval. Okay, so one more time. We know how to find the point estimate. Point estimate for these sessions, talking about the sample proportion. You only see one dot here. Means this is a one single value. 90%. We are talking about the probability. For the whole graph here, this is considered 100%, right? And then if we cut it here, in the middle part, we consider this is going to be 90%. And then this is what we want to construct the 90% confidence interval. Okay, this is point still talking about the point estimate. And then you could see this is a range of the values. And this range of the values talking about the 90% in here, in the middle part here. Okay, for example, if we want to construct 95%, 95% is talking about here, that will be including a little bit more than the 90% here. Since we're including more probability here, the range of the values is going to be wider. Okay, it will be longer in here. That will be wider, right? Means we do have a higher chance to estimate the population proportion than in the 90%. Next one, we could construct 99% confidence interval. So you could see 99%, we're going to cover more from the normal distribution, okay, compared with the 95%. So means like this range of the values will be much more wider. So it really depends what you are looking for. You are looking for only one point, one single value, or you want to a range of values. Of course, if you construct 90% confidence interval, then your estimate will be more accurate. It means like it will be really, really close to that point. But if you construct 99% confidence interval, it may not be that accurate, but you have a higher chance to estimate the correct value. And then from the point estimate to the side here, we're going to use the M. And the M here, this means the margin of error. Okay, margin of error. So the confidence interval will be using the sample proportion plus minus, that's a z star times the standard deviation. Okay, I'm going to explain this guy later. This is how you construct the confidence interval. Sample proportion plus, add something, the margin of error, you're going to get this point. Minus the margin of error, you're going to get this point. Okay, the SE here, this is talking about the standard deviation. We do have a formula for this guy. And when we draw the conclusion, we're going to say we have 90x%, depends on which one you're going to use. 90x% confident that the true values talking about the population proportion will be within this interval. Okay, margin of error. Tell us how far from the population value our estimate can be. Okay, we use the M equal to C star is the number tells how many standard error to include in the margin of error. Remember for the first example, we're gonna use the 2 times standard deviation because by the empirical rule, we know that 95% is talking about 2 standard deviation. So C star means one corresponds with a confidence level of 68%. This is by empirical rule. 95% will be 2 equal to 2. 99.7% that will be equal to 3. Okay, so you may ask, hey, how about if I want to construct 90% confidence interval or 91% confidence interval? Then we will have this table. Okay, some books will teach you guys how to calculate the C star, but for this book, they will be given here. Okay, so on the exam, I will give you guys this table. So you could check it out. If I'm construct 99%, then the C star will be equal to 2.5x. If I'm construct 95%, then the C star will be using 1.96. Okay, we use the 2 here because we know the empirical rule, that's a plus minus 2 standard deviation. But if we really calculate on it, actually it's going to be equal to 1.96. Okay, so confidence interval have the form, use the sample proportion plus minus the margin of error. And then you know the margin of error equal to the Z star times the standard deviation. Okay, so if I write it out, that will be the population proportion, that will be in between sample proportion minus the margin of error, and the sample proportion plus the margin of error. Okay, you could use the inequality to represent the confidence interval. Or you guys can use the interval notation here to represent the confidence interval. Okay, and then when we're finding the standard deviation, we're gonna substitute the sample proportion for the population proportion, since this is unknown, right? Because we want to use the sample proportion to estimate the population proportion. And we know the sample proportion here, this is unbiased, right? So we could substitute the p hat for the p here. And then estimate the standard error. Okay, now we're gonna combine everything together. We try to do the first example. So the HuffPost poll of 1,000 Americans found that 38% believe that there is intelligent life on other planets. A. Construct a 95% confidence interval for the percentage of all Americans who believe there is intelligent life on other planets. B. Would it be possible to conclude that 40% of Americans believe in intelligent life on other planets? So first, we want to check the condition for the central limit theorem. Okay, remember that 3 conditions? First one, random independent sample. Second one, we need to calculate the sample size. The n will be the sample size, which is going to be 1,000, times the sample proportion. So here, find that 38% believe that there is intelligent life on other planets. So 38% will be the sample proportion. So that will be 380, which is going to be greater than 10. And then we're going to use the sample size times the failure. So do the math. You're going to get 620, which is going to be greater than 10. So we'll fulfill the first and the second requirement. Do you remember what is the number 3 requirement? The population is going to be at least 10 times larger than the sample size. Okay, so we do have 1,000 for the sample size. 10 times of it is going to be 10,000, right? So for sure, the population in the United States has to be more than 10,000. Okay, so this is good. We can apply the central limit theorem. Now, after we check the condition, we want to find the standard error. Okay, standard error. Plug it in. The p hat will be 0.38. Use your calculator. You should get 0.0153, right? This is the standard error. Okay, now we want to find the margin of error. So we have the standard error here already. We want to figure out what is the Z star. Okay, Z star is related to how many percent of the confidence interval. We have the 95%, okay? Don't put two whites now, okay? 95% confidence interval. We're gonna check the table here. 95% confidence interval. That will be 1.96, okay? 1.96. So 1.96 times standard error, which is going to be equal to 0.029988. So we want it to 2 decimal space, that will be 0.03. Okay, right? Find the margin of error. And then construct the confidence interval. Okay, this is going to be the population proportion. That will be within sample proportion, which is going to be 0.38 plus minus the margin of error. We calculate the margin of error here already. Plug it in. You should get 0.35 to 0.41 here. So my population proportion, that will be within 35% to 41%. Okay, after that, make sure you draw the conclusion on the exam, okay? We're gonna say we are 95% confident that the percentage of all Americans who believe there is intelligent life on other planets is between 35% to 41%. Okay, make sure you guys draw the conclusion on the exam. So this is part A, right? Part B, what they are looking for. B, they ask, would it be possible to conclude that 40% of Americans believe in intelligent life on other planets? So 40%. So look at our confidence interval. We find it from 35% to 41%. And 40%, that is within here. So we're gonna say, it is possible that 40% of Americans believe in intelligent life on other planets, since 40% contain within the confidence interval. Okay, right? So one more time, I need you guys first check the requirement for the central limit theorem. You have to make sure they fulfill that three condition before you find the standard error. And then second, you want to find the standard error. And then find the margin of error. Okay, and then construct the confidence interval. Use the sample proportion plus minus the margin of error. At the end, draw the conclusion. Okay, I need to see how many percent confidence you are working on it. Okay, after you guys done, you could use your calculator to check your work. Okay, I'm gonna show you guys how to do it. And this is something you guys need to remember the formula. Sometimes they're gonna give you the sample proportion directly. Sometimes they only give you the number of success. Okay, the number of the success and the sample size. So you may want to calculate it by yourself. Okay, let's use the calculator. First, go to the stat and then select the test. And then we're gonna go down, find one proportion Z interval. Okay, using the Z, okay, we remember the margin of the error, that we do have the Z star, right? This is talking about the proportion and an interval, confidence interval. Okay, choose this one. Okay, X is talking about the number of success. So for my previous example here, we want to calculate the X, right? You're going to use the sample size times the sample proportion and times the p-hat. So we have a 1000 here times sample proportion will be 0.38. Enter. And then we do have a 1000 for the sample size. And we are working on the 95% confidence interval. Don't put the percentage here. Okay, convert it to the decimal. So that will be 0.95 and then go to calculate. So you're gonna see my sample proportion p-hat is gonna be 0.38. This is good. And you go to 1000. This is good. And then this is what we find out, 0.35 to 0.41. Here, 0.349. If you want a 2 decimal space, it becomes 0.35 to 41, 0.41 here. So this is good. Okay, so make sure you guys know how to use your calculator to double check your work on the exam. Okay, next one. I want you guys try to do it by yourself. Check the condition for the central limit theorem and then find the standard error. Find the margin of error and then construct the population proportion confidence interval. Draw the conclusion, okay? And then at the end, answer the question here. Okay, check your work. First, random independent sample. Second, calculate the sample size in here. For these questions, they give you the n. We do have a sample size equal to 300, but they didn't give you the sample proportion. They're gonna say, of the 300 voter survey, 165 indicates they will vote for the candidate. So this is gonna be your number of success. That will be your X in here. So we're gonna plug it in. You're gonna get 0.55%. And then now we're gonna check sample size times the p-hat, which is gonna be 165. That'll be greater than 10. And then n times the failure, you're gonna get 135. That'll be greater than 10 as well. So we fulfill the second condition. And then number 3. So we assume the population is gonna be 10 times larger than the sample. So this is good, we check the condition. Now, plug into the standard error formula. So you should get 0.0287. Okay, right? Now, margin of error. So what percent of the confidence interval we are looking for? We're using 99%, okay? 99%. So we're gonna go back to check the table. 99%, that will be 2.58. Okay, 2.58. The C star, that will be equal to 2.58. times 0.0287. So you're gonna get 0.0740. That would be the margin of error. And then construct the confidence interval for the population proportion. P-hat plus minus the margin of error. You should get this guy. Okay, right? Draw the conclusion. Okay, we are 99% confident that they will vote for the candidate is between 47.6 to 62.4%. Okay, answer the questions. What did they ask here? Should the consultant predict that the candidate will win the election? Why or why not? How can we know they're gonna be win or not? It really depends on the confidence interval, right? So they say, since the interval contains the possible values that are less than 50%, okay, less than 50%, the consultant may not predict the candidate will win the election. Okay, it's a 47.6 to 62.4. So we are not really sure. Okay, make sure you guys know how to do this kind of the questions. For sure, that will be on your midterm too. Okay, one more time, just to summarize here. Relationship between confidence level and interval width. Actually, this slide we talk about it at the beginning. When you have a less confidence level, 68%, then your confidence interval will be narrower. When you have a higher confidence level, it's close to almost 100%, then your confidence interval will be much wider. Okay, so it really depends on what you're looking for. That's it.